Welcome, hey folks, welcome to another episode of ML for Noobs. Now in the last episode, we tried setting up this service called Which Ryan Is It, right? And the core idea is that we have two Ryans. We have Ryan Reynolds and Ryan Gosling, and we're trying to figure out or train a model that can tell the difference between the two. And so when we provide it with an image, it would tell us which Ryan we are looking at. Now, the last model actually didn't work very well. So if you remember, we uploaded a photo of, which Ryan is this? So this guy, I think this one is Gosling, and it told us with almost 98% accuracy that this guy was actually Ryan Reynolds, when in reality he was not. So obviously there's something going wrong somewhere, and our job is to figure out what it is. And so that's what I'm going to be doing in this video. Just deep dive into all the different things that could have gone wrong and try and figure out how we can get them fixed. All right, so I'm going to start by just going through an overview of where we are right now. Now, so when we initially trained the model, and we actually had two folders, and we had a Gosling folder and a Reynolds folder, and these folders each included images, and these images are of the different people. So this is Gosling, a bunch of images of him in different setups with different backgrounds, and then there's also another folder for Reynolds, naturally, and similar structures, got a bunch of images that we had collected from Google Images. Now I'm wondering, so after we did that, so we actually did that setup and then we abandoned it. So what we did is we did a cleanup using this data image cleaner. Where is it? Data set formatter, and then we used, where's the cleaner? Yeah, image cleaner, which we passed a bunch of stuff to, and then it generated this cleaned.csv file. And so in our final training, we actually used clean.csv almost exclusively. And so I hadn't actually checked the contents of clean.csv. So I want to take a look at that and see what is actually going on. Like, there must be, whatever the issue is, I think clean.csv is where we need to start to figure it out. And so let's take a look here and let's see what's going on. So we have name and then label. All right, that sounds fair enough. And so a bunch of Reynolds are actually labeled as Reynolds, and then a bunch of Goslings labeled as Goslings. That doesn't sound... that doesn't seem like such a huge deal. How many rows do we have? I've got 360 rows, so about 180 images each, which yeah, that's about in line with what we were going for. I think we put the limit on the number of images, if I remember correctly, was 200. Yeah, max pics was 200, and then we removed a bunch of them, so I assume 20 were just corrupt, or they just didn't work for one reason or the other. So yeah, that seems reasonable. And so if we're looking at all this, it says Reynolds and it says Gosling, then okay, yeah, that seems about right. And so it's just referencing actual file names. So nothing crazy going on in there. So what it's doing, and I'm just going to try and interpret what's going on here, right? So we have our images, which we originally pulled from folder just based on the path. That's how we're going to tell. And then we ran the cleaner tool on them to clean them up. And then at the very end, we pulled all of the images from this cleaner tool. And then we ran the learner on this cleaner tool. And this cleaned.csv has all of our labels. And so it's actually labeled. It's not that it's not labeled. It is labeled. All right, and then we ran. But here you need to consider we didn't actually set up a validation data set, right? And so I'm left wondering, like, how did it decide what the split was going to be between training and validation? And it seems like what actually ended up happening is there was no validation loss because all of it was training. It just gulped up all of the data and thought, okay, this is training. And so what might have happened is when you later come to train it, it's already seen all of the images, and so we've overfitted it. I think that's what happened. So later, when we tried to run it on the same images that it had already seen, it was already overfit. And so I think that's what might have happened, is we kind of screwed it up. So let's see if we can run this again and run it through the same image that we had already shared previously. This image that failed, it was this image, and see what the reasoning is here, why it's actually doing what it's doing. All right, so let's do that now. After I turn on the AC because it's getting a bit hot. All right, cool. So let's just go through this really quickly. Path is Data Ryan's, and then we're downloading images. We don't actually need to download the images. All right, so we're just going to skip over that. And all right, so let's not download the images. No need to download the failed files, because there are no failed files. And then we need to view the data. Yeah, let's go ahead and view that. Let's make sure that it's loading the data properly. All right. And of course, this is image data bunch from folder. And so it's just pulling, so this is pulling images from the folder itself. We can see that it's loading up the classes properly, and it'll show you the batch. We're not actually going to be doing this. Like, our data is not going to be from a folder, but it's going to be from the CSV file, this cleaned.csv file. But I really just want to take a look at what the images look like. And then I also want to do it, so you definitely want to do this before you run it, right? So when I go here, this is Reynolds, that's Gosling, and then the image that we had, yeah, definitely Gosling, just based on what they look like. It's Reynolds, Gosling. Okay, yeah, I'm actually starting to tell them apart. It's with the beard, it's a bit more difficult. But anyway, so what I want to do is, okay, so that's all right. This is fine. This is fine. This is all fine. Now I want to switch to learning using, where is that? Our after custom learning rate. All right, so we want to do this from scratch. We're not going to be using, let's try to do it from scratch. Let's do that the first time. All right, so we're not going to use the original data bunch or data set at all. We're just going to be looking at things from the very beginning, as if we're training this new model for the very first time. All right, let's do that. And so oh, this is a cleanup effort. Let's not touch that. We don't actually need to touch the cleanup effort because we've already got the clean.csv file. So let's not touch any of this, and let's go to here. Yeah, retrain model a final time based on clean data. All right, sounds about right. So let's set up our data bunch. That's properly set up, and you can see here that we've done the split. So if I were to do insert cell below, right, and then I said data bunch dot, I think it's train dot, so len data bunch dot ds underscore train, I think it was. What was that? Data dot show batch, no. Data dot train underscore ds. Yeah, my bad. I really should be remembering all these things better. I haven't checked Enki today, so yeah. Anyway, so where were we? All right, dot train underscore ds. How long is that? That's 288. Excellent. And then we'll do the same for data bunch dot valid underscore ds and data bunch dot c. All right, so this looks about right. So we've got about 20% here, and then the rest, about 4 times that, in our training data set. So that looks good. And here, what we're going to do is we're not going to use the existing learning model. We're actually going to create a new one. So let's go ahead and do insert cell below. I'm going to comment that. So I'm going to say learn from CSV is going to be CNN learner data bunch, and then you have to provide it with models.resnet 34, and then metrics equals error. Is it error or error rate? Error rate models.resnet 34. Yeah, so that looks about right. Models.resnet 34 metrics. So okay, this is our final learner. That is the learner that we're going to be using. So let's go ahead and insert another cell below, and this time we're going to do learn from csv.fit1 cycle and start our learning process. Okay, and I want to see what sort of accuracy and results we get here. Okay, so let's do 4 cycles, and we're going to be providing it with a max learning rate, which is actually we're not going to be doing any of that. We'll do that later when we want to optimize it, right? So let's just run that, see what we see. Now, obviously, we should have training loss and we should have valid loss. So if we don't have that, then it means there's some sort of mistake somewhere. Wow, the error rate is horrible. It's 38%, 36%, 40%. That is horrible. 32%. That is pretty crap. And this is supposed to be on the cleaned data, mind you. So I'm a bit concerned by the sort of results that we're seeing here. I don't know why it would be that bad. I really can't understand why. Maybe it's a learning rate thing, right? I don't know. Let's see. So if we insert cell below, there's a learning rate finder. So I can do learn from CSV dot. I think it was something like that. Let's see. We did the learning rate finder. Yeah, so we can save and then unfreeze and then lr underscore find and then recorder.plot. All right, let's do that. So let's save it, and I'm just going to say CSV-0, and then I'm going to say, this is a really long name. I should have picked a shorter one. All right, anyway, so unfreeze, and then we're going to do lr underscore find, and then we're going to do recorder.plot, right? So, no, it's not learn, it's learn from CSV. Let me just copy that, and then recorder.plot. All right. Let me just make sure that's what we did here. Unfreeze, lr find, and then recorder.plot. Yeah, okay. Let's run that. So let's take a look and see what the lr find is going to give us. So maybe there's some room for optimization here that we can benefit from. Now, I don't know if it's going to make a huge difference or not, but I mean, just looking at this clean.csv, maybe there's something here. Like, are the images crap? Is that what's going on? Maybe the quality of the images that we have is just not that good. You know, that's one possibility that we need to consider. I mean, these are ultimately images I got from Google Images, but you know, we did run this whole cleaning thing. We did a whole cleaning spree, right, on the 200 or so images that we had. So my guess is actually the data should be okay. Like, we shouldn't have an issue with the data. I don't know why that would be a problem. But anyway, let's keep going. Let's try and run this learning process again, but this time. So learn from CSV, and this time we're going to do fit1 cycle, just like we did before, but now we're going to provide a max learning rate, and we're going to provide it. So steepest descent. That's what you're going for, right? And so steepest descent looks to me like a 3e3 to 3e4, right? That's where you're getting this action here. So 3e3 to 3e minus 4. I think if I recall correctly, Jeremy said that you want to go like one step, or one step left of where it starts to change. So 3e3 seems about right. So if I had to guess, I would say this is a really good assumption. Let's run that. Splice is not, was it splice or slice? Yeah, I don't know where I got splice from. It's slice. All right, so let's do that again, and let's do that and see what sort of results we're. Okay, that is pretty crap. I gotta say, like 50% error rate. That's a lot worse than what it was before. So we actually made it worse. Wait, you start with a small number and then you go to the larger number. That's how it works, right? Yeah, that's how we've always done it. Maybe that's the cause of the issue. Let's run that again. Take your time here. Take your time. All right, that's better. Here was 32. So let's see if we can. Whoa! Look at that. We're down to 11%. That's what I'm talking about. That is a huge difference. Huge difference. All right, this is looking good. I like this. This is much better. Now, I don't know if increasing the number of cycles is going to make a difference or not. But, since we're messing around here, let's just go the whole way, right? So let's provide 8 cycles. We're just going to go crazy here, right? 11%. That's the number to beat. 11.26%. Let's run it. Let's see what sort of results we get. I mean, it's always seemed arbitrary to me. Like, where did this 8 come from, right? Whoa, wait, 9%? Was that a fluke? Let's see. Whoa, 9% though. And epoch 0. I mean, he did mention that if it's going all over the place, then you probably have too many jumps going on. Like maybe you want to reduce the number of sites. So you also ended up at 11.26. You also ended up at 11.26. So that kind of tells me, all right, maybe you're okay, right? Maybe 4 is enough. I don't know. Like there was this section. Okay, wow, this is nice. This is not like it's going down. Okay, it jumped. So maybe that means the learning rate is too high, right? It could mean the learning rate. This learning rate right here is too high, and 3e3 is in fact too high. Maybe, could be, So I'm gonna cut it back here. I'm gonna give it another shot, and this time instead of putting 3e3, I'm gonna put it I don't know, like a larger value than 3e4. So 1e3. No, 1e3 is bigger. Like 3e3. All right, maybe something closer here. Maybe 1e4, or if we're being, let's do 1e4. So it would just be like this section here. It's just gonna take this section here, really small section. It's like it's not a huge section at all. Or you could just go 3e3, but 6e3 instead. 6e3. That seems about right. Or 7. All right, I'm gonna go with 7 here. Let's see what happens. If it's jumping all over the place, then it gives you an indication that maybe your learning rate is too high. If it's going really, really slowly, maybe your learning rate is too small. All right, it's definitely looking like we're doing a lot of jumping here. All right, you end up at 15, but you went through 47. Like, what on earth is going on? All right, you know what? Instead of putting a slice, I'm just gonna put in a single number. And that number is gonna be 1e minus 4, or 3e minus 4. All right, let's try that. You want to have a continuous or consistent drop in error rate. You don't want it going all over the place. That is what I'm talking about, guys. That is what this is much better. This is better. I can see like the results make a lot more sense to me. All right. One concern though is that I'm seeing a lot. The validation loss is significantly higher than the training loss. Like, what's going on there, right? What's going on there? Why is the validation? Is it overfitting? Is that what it means? I don't really understand what overfitting is, to be honest. I'm just vaguely, but I just hear people say that a lot. So yeah, that's where that's coming from. Anyway, let's see 1E4. All right, it's a bit higher. Let's see if we can hit that 12% that we had got earlier. All right, let's see if we, without everything just going all over the place, right? Let's see. Whoa, not 9%. Please be Lord. Please let that. Whoa, okay. Ladies and gentlemen, we have a winner. We have a winner at 8.4%. This is the sort of accuracy that I was looking for. These are the sort of results that I like. All right, so I'm definitely going to be doing a save right here. So learn from csv.save. What are we going to call this bad boy? We're going to call him CSV-1 because he's definitely an improvement over what we had before. Now, at this point, everything's great, right? At this point, life is good. We need to export. We need to export our stuff and just make it work, right? So I'm going to definitely don't want to run any of this stuff. I'm going to comment everything out. We don't need all of this. What is that? Like, yeah, you don't need that. All right. All right, not you either. Not you, that's for sure. All right, so now we can export our stuff and we can run it and see how it works. But here's the thing, right? You can actually do a test right here. You don't need to move it up here and export and download that 80 megabyte or whatever it is file. We can do it right here. We can do a preview, and I don't recall what the exact syntax is, but I don't need to recall it. It's right here. Where is that run.py? Here we go. All right, we just need to call learn.predict and pass the image. That's it. It's so simple. So let's just go ahead and upload our image. And so I'm going to put it into data here. All right, data, Ryan's. I'm going to upload my test image here. Okay. Okay. Why is everything in Arabic? Beats me. But okay, I want to go to Ryan's. Okay, desktop. There we go. All right, and I'm going to take my image. So this image over here. We know, so you and I, we know that this is, in fact, Ryan Gosling, right? But the model does not. And so this is the image that actually got screwed up in the last attempt that we did. So let's go ahead and run this. And we're actually going to do it before we export. So I'm going to do insert cell above. And I'm going to say my image is open image. And then I'm going to provide it with the path. Where is the path? Data Ryan's path / image.jpg, right? That's the image that we got. Let's just make sure that it's okay and we can see it. Can we see the image? Can you show me the image here? I'd like to take a look at it. All right, there it is. That's our image. So we know it's working. And then what we're going to do is we're going to go ahead and insert a cell below and then learn from CSV.predict. And we're going to pass this image and pass the same thing that we're doing here. And we're going to get some results. And those results are going to get displayed right here. So tensor and then 9.99 blah blah. And that's going to be our result. And so losses, we're going to take the losses. So at this point, I guess we could just copy paste this whole thing here, right? So underscore losses. This is going to be the same output that we have from before. All right. So that's going to be that, and then we're going to do JSON.dumps. Yeah, might as well just make it JSON.dump. Right? Who cares, right? And so I just need to do import JSON up here, and then run that, and then run this. So That's it. That is it. So you should do print json.dumps, all of that. So let's do that. Unexpected EOF while parsing blah blah. json.dumps got an unexpected EOF, like an end of file situation going on. All right, let's see if we unexpected end of file. Is it because we're not running it like that? Is that what's going on? Oh, okay, I forgot to put in the last. All right, so here it's saying it's 99% certain that this bad boy is Reynolds, and only, yeah, so it's basically saying it's Reynolds. But do you have classes? Yeah, classes already defined. What is going on? Like, why does it think that this is Reynolds? It's not Reynolds. It's not. Guys, this is not Reynolds. This is, I can show you what Reynolds looks like. Take a look at Reynolds. That is definitely Gosling here. That is not Reynolds. Look at his image. Look at Gosling. He's definitely, yeah, that's him. That's him. Why is it so hard? Why are you having such a hard time with this image? I just don't get it. I just don't get it. Like, why is it? Is it because the image was screwed up in? No, it's not. It can't be, right? No, it can't be. I mean, it was all right. Like, what is going on, guys? Gosling.csv. What is this? Gosling.csv. Since when did we have Gosling done? There's no such thing. We have clean.csv, and that's it. Clean.csv. Gosling is Gosling. Gosling is Gosling. Yeah, Gosling is Gosling. What? Why is this so messed up? Is it because the images I have are messed up? I don't know. And why is it so certain? Like, my problem is, if it was not even sure, I'd say, okay, maybe this image is messed up somehow, right? But it's so certain. It's saying 99.9% certain that this is Reynolds. Is it an image that it saw before? I don't know. Okay, look. All right. Maybe we can plot top losses and figure out what's going on here, because I really want to get to the bottom of this. I really do. But I'm just having a hard time. Maybe it's this image. All right. Maybe we should just try a different image. It's unfair? It's unfair enough? Yeah, let's do that. Let's try a different image. So I'm going to say, all right, Ryan Reynolds. All right, and I'm just going to scroll all the way. So it screwed up the Gosling image, and it thought that Gosling was in fact Reynolds. Let's see if we can find another image, not from the top 200, mind you. I'm just going to pick a different image that we haven't seen before. And wait, you know what? What if we Instagram Ryan Reynolds? All right, that's going to be an image that we haven't seen, right? Just get an Instagram image. That is so smart. All right, here we go. Oh, that's actually a video. This image. This would be perfect, and it's black and white. I don't know if that's going to be an issue here, but it should be all right. Let's see if we can get that image. How do you get an image off Instagram again? They don't make it easy. All right, that's the image. Let me just copy that. All right, that's our image. Let's save it. And that's going to be, this is Gosling, right? I keep getting confused here, guys. All right, call it Gosling. No, this is Gosling. That was Reynolds. Okay, then. All right, so I'm going to move it here, and I'm going to call him, he's not Gosling, but he is Reynolds.jpg. All right, Reynolds.jpg, that's the image that we want to upload. So I'm going to get rid of, so this, I'm going to rename that to Gosling. And we got it wrong, Gosling-X. And so here I'm going to upload Reynolds.jpg. And let's see if we have better luck with this. All right, so I'm going to go here and load up the image again. So this is Reynolds.jpg. Let's just see, make sure that we've got this loaded up. All right, wait for that, wait for it. I'm gonna get that. Now, one thing I haven't considered is, I haven't actually messed around with the size of the image, right? So that's our image. And maybe the learner works better when you provide it with a different sized image. I don't know. So let's run it. This, I'm going to expect that it accurately predicts this guy is Reynolds. But let's see. Gosling? What? Okay. Okay, this is very good. It looks like they're opposites. It's predicting Gosling when it should be Reynolds, and it's predicting Reynolds when it should be Gosling. I like that. At least there's some level of consistency. So it means that the classes are messed up. The classes are messed up, ladies and gents. Classes are messed up. So what if, wait, maybe I messed it up. When I said here, okay, wait. I'm getting excited. All right, so let's do data bunch dot classes. Let's see. Oh, here the classes changed. It was Gosling Reynolds, but here, oh wait, it's the same. It's same. It's still Gosling Reynolds, but in. Okay, no. Am I just getting excited and over nothing? Where am I? Where am I lost? All right, so here you have data bunch dot classes, Gosling Reynolds. Okay, all right, that's fine. That's fine. So what I'm gonna do here is I'm gonna say data bunch dot classes, map float losses. So that way we know we have the exact same class. So when you run that, what are you gonna get? What are you gonna get? Reynolds. Oh my God, we had it mixed up. It's correctly classifying this bad boy as Reynolds. Whoa. 98% accuracy, ladies and gents. 98% accuracy. So I'm getting excited. All right, let's do this again. And this time, didn't I delete this file? All right, let me just delete that once more. I don't know why it keeps showing up. All right, now I want to run goslingx.jpg again and see if we actually, so this is this, so I'm going to rename this. This is correct. All right, Reynolds, correct. Gosling X, that's what I want to check. Gosling X. Do you think it's going to get it right? What do you think? Give it a guess. Do you think it's going to come out right? Let's see. Let's run it. So this is Gosling. What does our model predict? 99.9%. Baby, that was so fast. I didn't even have time to react. Oh my God, 99.9. It doesn't get much better than that. Well, it could, I guess, if you go to 100. But man, our model is accurate. I love it. This is awesome. It's exactly what I hoped it would be. So now, Gosling was not, in fact, wrong. He was right. We just had the classes mixed up. Gosling correct, Reynolds correct. I love it. This is awesome. So at this point, we're going to export our model. So it's definitely not learn. It's learn from CSV. Let's export that bad boy. And he should be here. All right, that's our export.pk out. So let's download. Yep, save it. And let's just wait for that to happen. Now, I can't wait to actually get this running, right? We got it. We actually cracked it, ladies and gents. All we needed to do is retrain it, and this time again, like, we're not actually reusing the original set that we had because we diagnosed some sort of issue in that set. We're not really using that original set. What we're doing is we're doing it from scratch. And so yeah, the results, at least preliminary results, are very, very encouraging. We're getting very accurate results here, and I'm very happy with that. All right, so I'm going to spare you the boredom of staring at my download counter. I'm going to wait until the export file is completely downloaded, and then we can continue the rest of this video.